if I'm in a forensic setting, I have a sample with an unknown composition. I have an idea that it could contain explosives or illicit drugs, depending on the context of the case. But I'm not sure. It's also not pure. There are other components there. So a typical street sample with drugs will contain, in addition to the psychoactive substance, several other substances, like adulterants, diluents, tableting agents, for instance. But I don't know this. So when I do the measurement, I get kind of a composite signal for all these components in there. But I'm specifically interested, of course, in this illicit drug or this explosive. So here we need the data science to help us basically decipher the complex signal and let us know whether these compounds that we're interested in are actually there. You can take a bit more like a machine learning approach, but that requires a huge amount of data basically to have functional models. What Henk Jan has done is basically we take pure compound spectra of all the known constituents in a sample. So from research and cases, we know that there's maybe 15, 20 compounds that you can find in a typical cocaine street sample, for instance. And we take the pure compound spectra, and with the NAS model, basically, he's able to try all sorts of combinations of that to arrive at something that fits very well with the measured signal, and then we have quite a nice estimation of the actual composition. And that is much faster and requires less reference data for us to have a functional model. It lends itself very well for miniaturization, so you have very small, almost pocket-size near spectrometers, also being demonstrated here at Pittcon. And there are some additional very positive features to the technology. It's extremely rapid, so technology we work with, you create a reflectance spectrum in a few seconds. So when people talk about rapid analysis, sometimes they introduce methods that take a minute or 2 minutes or 3 minutes. And if you talk to people that are in law enforcement or customs, then a few minutes on the scene doing a measurement can feel like a lifetime. It can be too long for them. So that I think is something that is very attractive to near spectroscopy, that it is really a matter of seconds. So within 10, 20 seconds I can do multiple measurements on the same sample. So that is very attractive. When is it good enough? So when is there enough selectivity to say that with a portable technique you can do a measurement in seconds and also present that with confidence in court? And there you run against kind of, I would say, a little bit conservatism, right? So we've done it always in this way. I can't believe that it is that trustworthy if somebody does it that doesn't have a chemistry background. So that is something that I wouldn't say fight, but we debate, we challenge. I like to challenge that, but because I think, why do you think it is impossible to use such a technology? So I think we need to rethink a little bit how we deal with this. And it's typical for forensic science because you can do nothing. You can go on a crime scene and you can decide oh yeah, this person did it without doing any investigation whatsoever, if that person also admits to the crime, for instance. And you can do everything. You can spend 3 years investigating. And both scenarios are very undesirable, right? So how do you decide that, this is exactly what they need to come to a confident decision and trustworthy decision? And yeah, it's fascinating. I like that.